Hi, um, thanks for inviting me to Technical Tuesdays. Um, I wanted to give a presentation today um, about developing Lightning apps on LND. Um, so talking about the data model of Lightning and LND and new concepts to think about when doing development, making cool apps, making services. Um, so the big thing I want to focus on um, is I want to, there's a range of skill levels and um, ways to approach making an app in LND. And you can start very simple, just by doing the basic calls like creating a wallet. And you can get very complicated and very advanced. You can really push the limits of what can be done um, with all of the different APIs that are in LND. And I think that's where a lot of the opportunity lies right now, is in pushing the limits of what you can make LND do. How can you bring together all of these different APIs to create new apps and new services that don't exist already? Um, and I'll just take you through kind of every different type of API and some code samples. Um, so in this code sample, what I'm doing is what is required basically if you are approaching a LND that has no wallet already. So you're going to have to create a new wallet. And in order to create a new wallet, you need to generate a mnemonic seed for the wallet, which is something that you're probably familiar with if you're coming from Bitcoin or anything that's seed based. and LND has an API to create the seed. And I have my own, so you can kind of look at this code as if it's pseudocode, but I also have a library that I use with Node.js called the LN service, and you'll see that at the top, the required LN service. And what it's doing is it's wrapping a generated API calls that LND makes, which are using a format called gRPC, which is a Google way to define a schema for API calls and then deliver them. And it also uses an authentication form that I'll get into next. But here, creating a wallet is pretty easy. You just create a seed, you set a password that encrypts a wallet, and then you've created your wallet. And then you get into the authenticated calls. So before you make the wallet, you don't have any authentication details. But once you create the wallet, LND will create this thing called the macaroon. And the macaroon is kind of like an API token that you pass to LND, and you say, I have this API token, and it's a secret token. So that means that I have the rights to do different things. And you can see here, I have kind of like a model where whenever I talk to LND, I fold up my TLS cert to encrypt the token, to encrypt communications with LND. And then I include the macaroon, which I got from going into the LND directory, and it auto-generates macaroons there. Although in the future, remote macaroon creation may be possible where the macaroon never even lives on the machine. And then I provide the host name and the port to communicate with LND. And then I create this LND object that I just use all the time with every LND call that includes those three components. One thing that I think is interesting is to play with macaroons are more than just a simple API token. They have this possibility that you can add these restrictions to them. So I have an example here where I'm restricting the macaroon. So I've taken this access credential and I'm adding on these restrictions. So this restriction expires at will now make it so that this macaroon will only last for 1,000. Actually, it won't even last for a possibility that you can add these restrictions. It'll last for like another second, and it'll be locked to my IP. So and then you can further restrict macaroons by saying that they can only do things like create invoices, that they can do other like things that are very specific. So that's a LND kind of security and authentication layer. So let's say that you have created your wallet, or you are starting out with Lightning. The first thing that you really need to do is to think about actually not Lightning at all. You need to think about has a lot of different chain APIs. So you can create chain addresses. You can send to an address. You can send to multiple addresses. You can create nested addresses. And I have an example here of I create a chain address, and LND has different ways to listen for events that are happening. So I create a subscription to the chain address. And I'm saying, tell me about confirmations that are going to happen on this chain address. So I wait for that. I didn't include the send part. My logic here is a little bit wrong. But once you send to the chain address, it will. Oh no. Okay. Send somebody to me, and then I wait for that to be confirmed, and then I create a new chain address just to pass it along, and then I send it along to that new address. And you can get even very creative in LND because it allows you to even sign transactions and get access to the public keys that are inside of the HT seed. So you can use that like we use that in Lightning Loop in order to make submarine swap transactions by using the LND APIs. Okay, so in the wallet, then you can start to do exciting things. Like you can create channels. So one of the coolest features that has recently been introduced into LND is called PSBT funding. So PSBT is a partially signed Bitcoin transaction, but in LND's case, it actually uses a fully signed Bitcoin transaction, but in the PSBT format. And the idea is that instead of using the necessarily the on-chain funds that are on your LND, you can use an external wallet. So let's say that you wanted to use a Ledger wallet or a Trezor, and maybe you wanted to use Electrum or you wanted to use Bitcoin Core. So you could use those funds directly to fund channels. And so here I have an example of doing that. So I call the open channels call, and I'm going to make a channel with 1 million Satoshis with my partner on the network. And hopefully I have already a connection to them. So once I initiate this open channels call, I'm going to have 10 minutes before my partner my peer will give up on me. But so what I do in the background is I go to my Bitcoin Core wallet or I go to my Ledger wallet and I say, okay, I need to put together the funds that match this address and the amount that open channels call gave me. And once I have that transaction, and ideally it would be in a PSBT format, fully signed, it's sending to those addresses, and I don't broadcast it. I just have a fully signed transaction that would fund that channel if it were broadcast to the network. Now, not all wallets are supporting the new PSBT format yet, and that's something that is support for raw signed transactions is more common, and you can do that today in Electrum by pressing the preview button. So the thing is, though, that raw signed transaction is pretty similar to a PSBT transaction in that they have the same signature data. And I just have a method here that can convert the signed raw transaction into a PSBT. So even today, although LND is working on supporting raw signed transactions, even today you can technically open channels with the raw signed transactions, and that's what I'm doing here. And then once you have that transaction, you complete the flow by doing the fund pending channels. And this is pretty flexible. So you could fund channels from Wasabi wallet. You can, in the future, potentially we could say loop out into a new channel. So you could take your online Lightning funds and then use those off-chain funds to actually create a new channel. So there's a lot of possibilities here with this PSBT funding flow. Okay, so another aspect of Lightning to think about once you have some channels up is that Lightning has this gossip network. So in the Bitcoin network, we have this concept where our peers are telling us about blocks and they're telling us about mempool transactions. And they're also telling us about other peers so that we can maintain the network. So LND or Lightning Network has its own gossip network, but it doesn't gossip blocks. Instead, it gossips channels. So it's telling us all about different channels on the network. And of course, it's also telling about other peers and other nodes. And LND has a way to listen to this gossip with all of this information about channels, and you can subscribe to that. So I have an example here of subscribing to that flow, pseudocode example, where I'm listening to the graph and I'm listening for channels to be updated. And every time a channel is updated, I get my current set of channels from LND, and I take a look at those channels and I pull out all the public keys from the channels. Who's involved in all my channels? What public keys? And then I look at the update that just came. So every node in the network who has a channel also has kind of their view of the channel, and their view is I call it a policy, and that's kind of like their routing policy. Like how much funds will they allow to pass through? What's the minimum and maximum? What's the routing fee that they'll allow? Well, what's the base routing fee? Routing have two kinds. One is a static fee, regardless of the amount that you're sending, and the other one is a percentage fee, which I call fee rate. which is like parts per million. How much money does it cost to route through their channel? To follow in this example, I'm looking to see if the update from the graph is one of my peers. And if it's not, then I'm not going to do anything. But maybe it is, and because one thing that LND doesn't do is it doesn't store the history of all the different updates from your peers. So if you want the history, that's something that you have to write yourself. But there's a lot of interesting application possibilities if that is something that you want to work on. So here I just have a very simple ephemeral cache where I store what was the past fee rate of this node and what is the current fee rate of the node. What is this new updated fee rate? And then if they're equivalent, or if I didn't have a history, then I don't do anything. But let's say I hear about an update to a channel policy that affects me, that this is a peer who is one of my peers, and they're changing the fee rate to me. So in that case, then at the end of this function, I'm going to send out an alert to whoever's running this, and I'm going to say, hey, look, one of your peers, and peers nodes on the network have optional metadata about them, including an alias. So you can kind of set your name of your node. And so here I can give a message that says the name of one of your peers, they changed their fee rate to you. And then I say it was this fee rate before, and now it's this new fee rate. So I even see a bug in this code, which is previous fee rate should be called previous, but you get the idea. Okay, so now once you have the graph, the reason why you want the graph, why it's gossiped and synced to everybody, is it know how to get my payment through the Lightning Network from point and which intermediaries to use and what fees to pay them. I'm going to need to have the information about all the different channels and all the different nodes. And once I have that information, so on Lightning, it's a bit different from chain payments. An on-chain payment, you kind of broadcast it to the mempool, and then the tricky thing is, when is it going to confirm? So maybe you do some trial and error there with RBF, and you increase your fee to try to get it into a block. But those are kind of like that's the workflow of getting into the blockchain. But the workflow of getting into Lightning is different. What you want to do is you want to find a set of channels that are going to have liquidity. So that means that the balance is on the correct side and they're ready to forward your payment. And they're not going to mess up the payment. They're not going to hold it. They're not going to delay it. So there's all these things that could potentially happen on a route. And normally when you make a payment in Lightning, you might not always see it because the app might be hiding it from you. But it's trying route 1, it's trying route 2, route 3, route 4. And LND has a system in it which is going to try to look for the cheapest fee, but it will also take into consideration past failures with different routing nodes and past failures with different channels to try to also help you find an effective route without wasting a lot of time on things that are not working. And one thing that I think is more advanced when it comes to payments, so of course, there's regular payment APIs. So there's 3 different types of ways to make a payment using LND. There's one is you can pay with the details of the payment. You just specify the destination, and there's a value with payment, and you can say the amount, and you can fill in all the details. But we have this thing in Lightning called the Bolt 11 payment request, which is a way to serialize all those details into just this big long string. So if you've used Lightning, you might have seen it. It looks kind of like a regular Bitcoin address, /32, except that it's LN and it's really super long because it's basically serializing all of these different details. So you can craft your own. Let's say you don't want to use LND's internal pathfinding, or you want to modify it somehow. You can make a payment along pre-specified routes, and you can also modify the fees that you're dropping off at each hop, that kind of thing. So one thing I like to do when I'm making payments, it's more advanced, it's not necessarily out of the box, is before I like to do a test payment to make sure that I can do the pathfinding, but without committing to possibly paying. And that helps. Like, let's say that I try some paths, and maybe one of the 40 nodes is just holding it. And that doesn't happen too often, but just to and try to figure out what is a good route. You can do this thing where you're probing, and what you're doing when you're probing is you're changing the payment hash, the payment like hash that corresponds to the hash, changing that to a random number or an impossible hash. And the nodes that are forwarding it will not know that, but the final node will know it. And so when you try to pay the final node, it will say, I don't have this pre-image. I am not able to accept the payment. So we'll get back to you, and then you'll know that you were able to probe the destination directly, and you can send your real payment then. And what I have in this code example is I try to figure out, okay, what can be my find a route, trying to find a payable route. So that's what this first function does. And I want to know kind of who I'm paying to. So nodes in the network have aliases, and potentially you won't always find a route. Maybe you just try looking for a route, and at this moment in time, or this node maybe is offline, or there's maybe you're having connection issues. So there might not be a route, and so if there's no route, you have to deal with that case. And that's what the first if conditional does. There also might be this case where you can find a route, but double check it and say, okay, do I really want to pay this? My fee is going to be XYZ. And in Lightning, you don't necessarily know what fee you're going to pay ahead of time, because you don't know exactly which route that the path of your payment is going to take. But if you probe, then you know that this route is a working route, and so you can say that the fee of that route is XYZ. You can present that to the user and say, do you want to pay this? And maybe the fee is very minimal, and in that case, then just pay the route that you just found. Okay, so once we've started making payments, you might want to start getting money. I think Lightning is a great opportunity to make some money, make some Bitcoin, stack some sats. So what I have in this example is using what I call HODL invoices. And a HODL invoice works differently than a normal invoice. So when you create a normal invoice, you create this invoice, and create that payment request that I talked about, which is just this big long string that you can hand out to people, and then they can scan it with a QR code, or they can just copy and paste it into their app and pay you. And normally what happens is once the payment reaches your node, once you can receive and take the payment, LND will just automatically accept it. It's generated a secret there that corresponds with that hash. And now LND is happy that it sees that money coming in. And what's technically happening under the covers is that your peer is attaching an HTLC to your node, and it's saying, here's this HTLC, and if you knew the pre-image and if you revealed it to me, you can take this money in the HTLC. And normally you just reveal the pre-image, and that all happens automatically. But what HODL invoice does is it says, hold on, you don't actually need LND to know the secret. Instead, LND can say, if a specific hash comes in, I want you to hold on to this HTLC that's attached to me and wait for further instructions. And here I'm creating a HODL invoice with a secret that I generated myself. And a secret is just some random, cryptographically good random bytes. And I created this secret, and then I shared the hash with the person who's paying, and I can create a payment request for that if I want to. But I shared the hash with somebody who's paying, and then I then subscribe to the individual invoice. So LND offers a subscription method so that you can listen to different invoices. And what that's going to tell me is, oh, when that person goes to pay, when the payment is finally attached to me as an HTLC, LND will say it's in a hold position right now. And that's something that you need to deal with now. Is you need to figure out, do you want to cancel this and you want to say, no, I don't have the secret, I don't want to take the money, or I do want to take the money. And you can really do anything in this period. So I have here this subscription and it's waiting for this invoice to be held. And once it is held, it's actually is just settling it. So I'm kind of reproducing what LND is doing internally by myself. And you can use this for all sorts of purposes. So like if you're a merchant and you want to delay acceptance of funding of payment until you are sure that you're able to deliver goods. So let's say some people have two different people put the same item in their cart, and then one person is faster to pay, so that the item is now missing from your inventory. Well, now you can reject the payment. And if you were just using Bitcoin, that would be a difficult situation. You'd have to refund them. You have to make a payment on the chain. But canceling is a costless operation. You just say, sorry, I can't take your money. And you could do the same thing if you were an exchange. Maybe somebody deposits to the exchange, but could be that they've closed their account. So if you're using this flow, you can say, oh, your account is closed. I'm not taking your deposit. Okay, so maybe now that you've got funds, you've got channels, you're making payments, you're making invoices, you're listening for invoices. I think kind of a third path that is one that I think is a lot of fun is doing is becoming a routing node yourself. And there's a new API that actually isn't in any release of LND yet that I'm pretty excited about. And it's called the HTLC interceptor. Although what it's doing is basically telling you that other people want to do forwards through you. So they want to forward some money through you. And this allows you to listen for those forwarding requests. And this new API says, whenever you get in a forwarding request, you can now do some business logic and say, okay, do you really want to forward it? And I have like a pseudocode example here of what if you wanted to like subvert the Lightning Network, and instead of a network for sending payments, what if you wanted the Lightning Network to be about delivering data? So you wanted to say that people could have some protocol to tell you that there's certain little chunks of data that they want you to store. And then when they want that data back in the future, they would send a payment to you. And you would reveal the data to them and then get paid for storing and serving that data. Well, that's something that I thought about for a long time in the past as something that would be an interesting use case for Lightning. But now with this API, it's something that you can do in very easily, because this forwarding request API allows you to actually short circuit the whole routing protocol and say, instead of forwarding the request onto the actual destination, I'm somebody who knows this data. So you could send your request through maybe 3 or 4 or 5 hops of all these different people who are supposed to be saving the file for you. And then the first one who is able to actually service a file can collect the money and cut off all the future hops on that path. So I think there's lots of different fun things that you could do now that you can have control over whether you want to accept or reject a forward request or settle it directly. And if you are doing routing, like the normal things that you would be doing are not doing this. Normally you'd be doing rebalancing, which is similar to doing a payment, except that you pay yourself. So if you have too much liquidity, so you have too much balance on one channel and you need to move it over to the other channel to minimize errors that are based on not having enough balance in one channel, you would do a payment out one channel and back into yourself. You can do that with the routes that I showed before. And then you might also want to think about your fee rates and your maximum HTLC, and all of those APIs are available to you in LND. Another thing I wanted to talk about that seems very simple, but is actually kind of complex, is balances. So LND actually has a few different places where balances are surfaced to you. And the big 3 topics are: you have your chain balance, your chain funds, and you have your channel funds, off-chain funds, and you have another type of funds which are like limbo funds. And that's kind of, there's lots of different types of limbo funds. So when you even break down these different types of balances, there's more subdivisions. So you might be familiar, if you know about Bitcoin, you have a balance, which is your on-chain balance, which is confirmed. And you also have pending balance, which means that there's unconfirmed transactions that are potentially going to pay you money, but you don't actually have it yet. So maybe you shouldn't count on having it because it could be double spent. So LND has that too, of course. But channels have some subtleties just like that. Whereas, like, let's say you have an HTLC attached to you by your peer. Well, maybe you know the pre-image to it, but it hasn't been settled yet. Maybe you don't know the pre-image, or the pre-image is somewhere else. The secret for that HTLC is somewhere else. So there's kind of like this same concept of there's this pending balance. There's these potential money that you could claim, but it's not necessarily yours because HTLCs have a timeout. So if you don't settle if you don't finalize it by folding that HTLC into the regular channel balance, then the money won't really be yours. It could potentially go back to the other side. So it's kind of like in limbo. There's another balance concept, which is that in order to be secure that you can get the money out of your channels, and that both sides are going to get the money out of their channels, every channel has this thing called a commitment fee. And that sometimes confuses people. And what that is part of the balance of whoever opened the channel is assigned to the commitment fee, meaning that it is on a commitment transaction. Like every channel, it corresponds to a commitment transaction, a transaction you could broadcast to the blockchain. And there's a fee associated with that, and the fee is the commitment fee. And here I have a code example of calculating what that is. And that's going to go up and down. So sometimes people see their balance and it's going up and down, and they think, why is it going up and down? That's strange. Normally I have a Bitcoin balance and it's always steady. And the reason why is because your commitment, the amount of money that you would theoretically have to pay to fees, is going up and down. And then another thing that you might want to calculate is inbound liquidity. So in Lightning, if you want to be receiving money, or if you want to be forwarding, you need this thing called inbound liquidity, which just means that other people's channels have balance on their side. So here I have a function which calculates what is my inbound liquidity, how much balance are other people assigning to me. And there's even more complexity when you get into the limbo states. Like, let's say you have time lock balances. So potentially you have time lock balances in that you tried to make a payment and it timed out. Maybe you were probing, and the probe, you know that the probe cannot resolve in the money being taken with a pre-image because the probe uses a random hash. But LND doesn't know that. So it will represent that money as being in this pending state. It's read time lock. So if the channel is uncooperatively closed by yourself, by your own node, there's potentially up to a 2-week wait time where you have this balance, but you're not allowed to spend it. And it's conceivably, it's not even yours yet, because the other party, if you're doing an invalid broadcast of this channel state, which hopefully never happens, the other party could actually have an opportunity to take the money back. And after the time period, it will be, LND will sweep that money into your sole control, so that's no longer an issue. And then, of course, channels. When does a channel balance part of your channel balance? When you open a channel, LND will wait a certain number of confirmations before it actually considers it to be part of your channel balance, and it will do it even progressively. So, depending on the amount that's being opened, it will wait more confirmations. So yeah, balances can be a little bit complicated to think about, and maybe aren't as fun as this API that I think people should probably play around with, which is called TLV or Keysend. You might know it as like WhatsApp. There's apps like Sphinx and Juggernaut. And the idea is, what if we could attach messages to payments that we're sending around the network? And this is an idea that even goes back to Satoshi. original Bitcoin idea was that you could attach a memo to your payments. And now with Lightning, you actually can attach a memo to your payments, although it's not done super frequently. And so here I have a code example of actually sending a message. And in this message, I'm demonstrating doing a key send and also attaching a message. So what a key send does is instead of doing the invoice flow where the receiver makes the invoice, you actually send a payment, and just like the probe, the routing nodes don't know that there was no invoice created by the receiver. But what you're doing is you're actually embedding in the message that's encrypted to the final hop, you're embedding the secret that you created as a sender. And when the receiver sees that HTLC attached to them, they also see this little message attached to them. And they say, oh, there's this little message that includes the secret pre-image that I can use to take this HTLC. And you can see that represented here. It has this really weird number, 548237. And what that is it's like, this is a type of message that includes a pre-image. And it's not necessarily a standard, but this is what LND will support if you turn on Keysend. And then you just send it the secret that is just a random bytes. And then here I also have, this is another kind of very unofficial protocol, but if you fill in the type 343493334, you could attach a message there. And you can say, here's a little short text message. So this code will look for a destination, and it will say, send them a message that says, yo, and send them, and along with that, send 100 Satoshis. So you'll just make this payment. So that's some pseudocode to just do a key send and send a message. And you can see it's pretty simple. I'm very excited about this messaging concept because what it allows for is it allows for extensibility of services that are built on Lightning. And this is what I really hope that people do build with LND is more Lightning services. You leverage like the native capabilities of Lightning to make interesting applications that can only be done on Lightning, or that really leverage this kind of network, messaging network. And I've worked on certain services myself, and like submarine swaps. Lightning Labs offers this service called Lightning Loop. We have worked on this concept called BOS scores, which is a way to an API that Lightning Labs has used to kind of figure out, like, make recommendations of which nodes that you should use as your routing nodes. Who should you peer with? Let's say that you're new to the network, who would be a good routing peer? And the BOS scores is just a way to get an API for that. But in the future, I think we can offer these APIs which will be based on this native messaging. And I have an example of that here. And in this pseudocode, what it's doing is it's saying, let's say that I get a key send, and the amount that they're sending me is 1,337 Satoshis or more. And when they send that to me, I'm going to look to see if it is sending me the special type 8675309 type. And if they send me that type, then I'm going to take the money, and I'm going to actually, I've already taken the money at this point. So what I'm going to do is I'm going to create a SMS. So I'm going to use Twilio, use my API, my account at Twilio, to send an SMS to where that this person who sent me a payment wanted me to send it to. So now I have a fully native SMS API that's launched on the Lightning Network, and all anybody has to know in order to use this API is all they have to know is my public key. Who am I on the network? And I don't necessarily even have to have a Tor address. I don't even have to have a regular address. All they have to see is I'm on the network, and they have to know that if they send me a message with a text value or with this type value and this amount, that I'm going to send a text message yo to whichever number they want me to send to. So I think that's really cool. And there's lots of more applications that could be built based on this TLV concept. And it will be improved in LND. There's pull requests that you could like hold on to the TLV, just like I talked about with hold invoices to help you service orders. You could build a store on it. You could do all sorts of things. So that's a pretty cool API. And LND really does offer you a lot of different APIs that get to that allow you to kind of get sophisticated about the applications that you're building, because I talked about before that you can get public keys out of your transactions using those. You can something that you can use for the TLV messaging is actually you can sign the statement that that you're sending to the destination, so they know the receiver. Normally in Lightning, you wouldn't know who is sending you the message, but using encode the signature, and you can use LND's APIs, signing APIs, to create a signature that signs over your message. So, um, and this example, I'm actually using an interesting API in LND, which is to compute a Diffie-Hellman secret. And what that's doing is it's saying, I want to create a shared secret with another public key. And in this case, I'm just actually using my own public key. And I want to create a derivative secret here. And what I want to use a secret for is to encrypt something. So let's say that you wanted to encrypt a file. So you want to, create a secure way to back up something, but you want to make sure that the person you're backing it up is not able to read it. So you can actually use LND's seed, use that master key that you can now use to encrypt something, and you're doing symmetric encryption, but you're able to asymmetrically deal with other people or deal with yourself using public keys, and that's something that can be recovered from the seed as well. So I think there's a lot of, if you're making protocols that are offering Lightning native services, this is an API that LND has right now that you can start leveraging. Another thing to think about, there's so many different aspects, so many different parts of the data model to think about. I think people take it for granted who have been in Lightning already, that everybody knows about all of these different things, hold invoices, TLV, that they have a broad coverage of all these different APIs. But I think even I am still learning about how different APIs work, because there's just so many different components to running a Lightning node, and so many new features that we're thinking about. So one of these features is called the static channel backup, and that's something that LND offers in a way to try to make a foolproof way to secure the funds that are in your channels. And it's actually using a very simple system, where all it is doing is it's creating a record of who your peer is, and then if you lose data about your channels, which is the most common way that people can lose their money, is they lose their database, or the database becomes corrupt. If you have this backup file that just will remind you of who your peers were, you can take that backup file, and it has some extra metadata in there, and you can go to all your peers and you can just poke on them and say, hey, can you force close this channel? And when they force close the channel, because they have a copy of the channel state, and because the keys are your keys, they'll go to the blockchain. You'll be able to recover your money back. So here I have a code example of using the things that I talked about before. So let's imagine that there were and this is a contrived example of the pseudocode, but let's imagine that the backups are very small, and you could attach them actually as messages. So one thing you could do is you could say, maybe there's a TLV service out there who will store my backup for me. And backups in LND are automatically encrypted. So it's safe to actually put them in all sorts of different places because they're encrypted to your HD seed. And that's something that you could do. And this is basically a one-liner, is when you get a new backup, you subscribe to LND's backups. When you get that backup, you just send it to wherever your backup service is, and you're doing it all within the Lightning Network and using just LND's APIs. Finally, I want to cover, just for kind of completeness, like the watchtower system that LND has, and that's something that is very useful when you're considering the static channel backup system. So let's say that you are just relying on these, just are not maintaining the channel state. All they're doing is just reminding you of who you could connect to in the future to get your money back, and who could you poke and say, can you please close this channel? And some people are a little bit worried about this because, and rightly so, because if you're telling your channel partner that you've lost your data, that might be seen as an invitation for broadcast an invalid state of the channel. Are they actually taking more they're entitled to, an out of date state? And if you don't have the state, you've lost your database. You no longer have the ability to contest that money. So that's potentially where watchtowers come in. So what watchtowers are doing is you're sending them an ongoing updated kind of a good state of the channel. Like if your peer broadcast a bad state, you can contest it with an updated state, and even a better state because it includes a penalty that goes back to you. So if they try to cheat you, you can actually take all their money. You can take all their money that they have in their side. So even more than just the that you would normally get. So you can run one of these watchtowers, and watchtower isn't all that sophisticated because you're just basically giving it regular chain transactions, and these regular chain transactions are encrypted, and they're encrypted with an ID, so that nothing can go wrong because the watchtower itself is not able to even get access to this information unless the offending scenario happens and your peer tries to cheat you. So I have a code example here. Let's say that I want to connect a watchtower. And so LND can run in kind of watchtower server mode. And when it runs in that server mode, it has a separate public key and a separate address. And that's that's kind of like its tower address, its tower public key. Here, which is like saying, okay, I want to figure out what on my tower LND, I want to figure information, and then on my regular LND, I'm going to check which watchtowers I already have, and if I'm not connected to this watchtower already, I want to connect to it. So it's pretty simple to set up watchtowers as well, although they're only recommended for running yourself for redundancy purposes. The fun thing I wanted to share, it's not all about making your own apps, although there's so much opportunity to make your own apps, make your own services, and potentially lucrative opportunities. It's not necessarily you're going to make a fortune on Lightning, but this is something that you could do that would be a lot of fun, that you could potentially integrate into your platform that is seeing good growth, and something that can definitely make you some side money if you put some effort into it, make something that really helps people is useful. And I wanted to highlight also some open source projects that you could contribute to. So maybe you don't really want to offer a service, you just want to kind of help the effort overall, or you want to you're already running services and you want to find interesting projects. So and I also think that some of these projects can build upon each other. So, the source code that I linked at LN Service, I've published an open source code. It's all MIT licensed, so feel free to copy and paste it or include it in your own code if you want to. And I encourage more people to share code, to collaborate, share their efforts. So some of these projects, a project I think is interesting called Thunder Hub. You could contribute to that project. The idea is to help operate your routing node, and or help operate any kind of node, but give you kind of a graphical user interface, a web interface, and that's using React. And I think that's interesting also because it uses like Node.js and some of the code that I published. So I think some of these cool features that are coming in LND can also be surfaced in applications like Thunder Hub. Another interesting application, and there's really a series of like proof of concept applications. Boltwall, so Tyrion, if you go to their GitHub or you go to Buck Purley's GitHub, you can see that they've experimented with making. So I created yalls.org, and they've created kind of like a do-it-yourself yalls.org, something that you could run yourself. You could customize and make a way that people could pay you to read articles and get paid to publish articles. There's something that I've heard about. I don't know too much about this thing called Dazar, which is a way to like maybe make peer-to-peer networking that has a monetary component. And although I don't know too much about Tazar, I'm excited about this concept that we can create more, like I showed you with the TLV service. We can create like fully peer-to-peer solutions that, they don't require DNS. They don't require you get a good domain name. They don't require you set up a corporation. You can basically just turn on your node and now you're offering a service, which I think is pretty exciting. And I think it's also really good for peer-to-peer networks to be able to include micropayments, because the big problem with peer-to-peer networks normally, peer-to-peer software, is that it will have incentive problems. Somebody will be a burden on the network. Somebody's going to take more than their fair share. And with Lightning, you have the opportunity now to make if somebody's consuming too much of a limited resource, you can now make people pay to solve that contention. Then there's SAP Desktop, which I think is great for people who are looking for the privacy of the Lightning Network. If you're making on-chain payments, you are kind of revealing your UTXOs to the world. And I think one thing that's nice about the Lightning Network is that you can make payments, and it's not necessarily a blockchain record that's going to be there for all of history. And I think like desktop wallets that makes this super easy to access Lightning, like Zap, are really the future there. So if that interests you, I would definitely contribute to that as an open source project. And then in the real world, I noticed this project to do Nespresso purchasing with Lightning. And that's something that I think you can pay them to take it, but they also have open source. They have it on GitHub, their designs. So potentially you could just make this yourself. And it has a point of sale system. So you could make gadgets in the real world. Like, let's say that in your office you have some Bitcoin enthusiasts, and you have an espresso machine. Somebody's always taking the flavor you like. You could say, okay, well, we've got a limited numbers of those Nespresso capsules, and if you want it, you're going to have to pay like 5 cents or something in order to get that coffee. So there's all sorts of fun projects you can do in the real world that leverage Lightning. So there's just so many opportunities, and I hope people take advantage of it more, find time to experiment more.